Right here, how to solve simultaneous equations when one is linear and one is quadratic. Part 2. You've done all the hard understanding and the hard work in Part 1. Part 2 is a much shorter film, just to deal with how to solve your equations if they're given to you in this form, rather than both as y equals. Now, if you've got two simultaneous equations that look like this, the best thing to do is to, in this case, take the top equation and to make x the subject. So I'm going to subtract 2y from both sides. And now I've got an expression for x. And what I'm going to do is I'm going to take that expression and substitute it into the second equation instead of x. So I'm going to start by writing down that second equation, x squared plus y squared equals 25. Now I'm going to write it down again, but instead of the x, I'm going to write 10 minus 2y, because after all, x equals 10 minus 2y. Okay, now I've got an equation with just y's in it, so I'm going to solve that equation. 10 minus 2y squared means 10 minus 2y times 10 minus 2y. Copy down the rest. Right, multiply out those two brackets. 10 times 10, 100, minus 20y, minus another 20y, minus 40y, plus 4y squared, plus y squared equals 25. Tidy up the left-hand side. 5y squared minus 40y plus 100 equals 25. Now, that's a quadratic equation. Set it equal to 0 and then factorize. So I'm going to subtract 25 from both sides to set that equation equal to 0. Now I'm going to look to factorize the left-hand side. Before I do anything else, I see there's a common factor, 5. 5 lots of y squared minus 8y plus 15 equals 0. Now, can I now factorize that quadratic expression? It's going to be a y and a y. Multiply to a positive, add to a negative, minus and minus. It's going to be 3 and 5. So my two solutions for y are that y equals 3 or y equals 5. Okay, now each of those values for y are going to give me a value for x. How am I going to find that value for x? Well, I'm going to use this expression up here, because I know that x is 10 take away 2y. So if x is 10 take away 2y, if y is 3, then x is 10 take away 6, 4. And if y is 5, then x is 10 take away 10, 0. So my two solutions are if x equals 4 and y equals 3, or x is 0 and y is 5. So that is how to solve the equations when they're given to you in this form. Right, here's one for you to have a go at. Okay, what I suggest you do is to pause the film and have a go, and then play the film and watch me do it. If you want a hint, then start by taking equation 1 and making x the subject. Okay, pause the film now if you want to. Right, I'm going to solve this now. So I've got x equals 2 take away 2y. So I'm going to write down the second equation, and then I'm going to substitute 2 minus 2y into that equation instead of the x. Okay, remembering that 2 minus 2y squared is 2 minus 2y multiplied by 2 minus 2y. Copy down the rest. 2 2s are 4 minus 8y plus 4y squared plus a y squared. Okay, tidy up the left-hand side. 5y squared minus 8y plus 4 equals 1. Now, subtract 1 from both sides. 5y squared minus 8y plus 3 equals 0. I've set it equal to 0. Now I'm going to factorise. I can't see a common factor. It looks like I'm going to have 5y and y. Now, I multiply to a positive and add to a negative, so they're both going to be minus. And because it's a 3 there, it's either going to be 1 and 3 or 3 and 1, isn't it? And I can see that it's going to be 1 there to give me minus 5x, and a 3 here to give, minus 5y, and a 3 there to give me another minus 3y to give me minus 8y. So now I can read off my solutions. Y is going to be 3/5, or y is going to be 1. Right, I better find x now. X is 2 minus 2y. X is 2 minus 2y. So if y is 3/5, then x is 2 minus 6/5. So that leaves me with 4/5. Gives me the solution x is 4/5 and y is 3/5. Or alternatively, if y is 1, then x will be 2 minus 2, which is 0, giving me the solution x is 0 and y is 1. So there are my two solutions to that simultaneous equation. Right, if you found that useful, then please hit like. If you've got any questions or you'd like to make a comment, please feel free to make a comment in the comments and I'll respond. And lastly, if you haven't already, please consider subscribing.